This is one of the pocket money kits. As far as I remember, it's still in its VariaBoard version rather than a PCB version. The idea being that you have a trigger at the bottom. If you bring the trigger down to 0, you'll start a sequence where A will change state from high to low, then B will change state, then C will change state, and so on all the way along. And you can use 2 of them, as Keith did. I use 5, or you can daisy chain that output becomes the input to trigger the next one. So you can have 10 in a sequence, you can have 15 in a sequence, whatever. You can have as many as you want to add together in the sequence. So the idea being that the outputs then follow, output A follows input A, output B follows input B, and so on. We've got a little trimmer here. If we put a jumper in A, we can then adjust the trimmer anywhere between 0 and 10 seconds, and then take the jumper out. And now when you trigger it, A will have that amount of delay. Put the jumper into B, tweak the trimmer, take the jumper out, and you've now set B to its timing. If you can make the rest of them 0, so if you trigger it, you only get 2 to work, or you can make them all work. And every one of these can be a delay in the output between 0 and 10 seconds. That's the idea behind the sequencer. That's the circuit diagram, very, very simple. A bunch of inputs and a bunch of outputs. And each input's got its own pull-up. So normally E is held high until you put in the jumper, in which case the pit's going to spot it, and then wait until you set the value from the trimmer. And then when you unplug it, the jumper, it then stores what that setting was, and that gives you the delay. So there's not a lot to the actual hardware side of it, and the code is relatively simple as well. That's at its simplest, taking out all the sort of setup parts, but the main loop is if you've triggered it low, then do a forward sequence. And as long as it stays low, just wait. And the minute the trigger goes high again, do everything in reverse. So as long as it keeps low, you'll do 1, 2, 3, 4, 5 in the sequence, and all these will stay low. So all the lights will stay on, all the servers will stay in that position until you make the trigger high again, in which case they'll all one at a time go back off. And that's it, that's the forward sequence. Nothing fancy at all. Wait a while and then make output 1 low. Wait a while, make output 2 low, and so on. And the delay value in here decides how long it'll wait before it takes it low. And to do a thing in reverse, in other words, when we make the trigger high again, we do the reverse sequence. And the reverse sequence makes them go high again. So that works fine. The question then is, how do we store these delays? When you're doing this, you can do things in 3 ways. You can actually, like the easy points, for example, all it does, every time you boot it up, it reads the trimmers. It's not saved at all. Some other bigger systems, when you've got lots and lots and lots of variables, will store it as a file, so that when you first boot up, you'll read a file as your variables. In this case, we've only got 5 variables, 5 delay variables, in which case we can store it inside the chip itself. Those who've been looking at the PICs will know we covered this before. That's the 676 chip that we've looked at. That's the one that's used in the sequencer. And it's got 3 lots of memory. And the one we're looking at here is the EEPROM. That's the memory that is going to store the variables. And even though the power goes off, they maintain the store of those variables. So when you first boot up next time, they're there to be read. And there's an example of it. We've got our include to say which chip we're using. We've now added an include to say we want to handle EEPROM. And that's part of the standard set of includes. And then the procedure then, before you do anything else, after you boot up, is read from the EEPROM and store them one at a time from location 1, location 2, location 3 of the EEPROM into the various variables. And then they can be used in that sequence I showed you earlier on. So that's, you've stored them already, and you can read them from this particular procedure. How do you get them in there? Well, you can read the trimmer. We covered that before, reading analog values. It returns between nothing and 255. I've put a line in the code for the sequencer saying divide it by 25, which roughly will give you between nothing and 10. So if you wanted greater than 10-second delays, then you can make that, divide it by 10 or 12 or whatever value you want, divide it by 2, and you can have, therefore the range will become greater. But I thought most animations, the sequences, 10 is probably as much as you need. And the code simply says, read the value, and if jumper 1 is in, store it. We've looked at earlier about EEPROM read. This is EEPROM write, and we write to a location. So I've got one command that will write values away to EEPROM storage, and another value earlier on that can read them from EEPROM storage. So far, so good. That's how the sequencer works. And then we came to, as Keith mentioned, the WTV020 sound player, which is equally simple in its hardware. That's it. A voltage regulator, a speaker. These are optional. These will make a LED illuminate while it's playing a track if you need that. In most cases, we wouldn't need that. And then you've got a single button. You press to bring this pin low to start, but you've got to bring it down low again to stop. And that's where the problem Keith came across with the code. You have to pulse it on and pulse it off, whereas a sequencer in its forward sequence keeps them on all the time, and then they all go off. So what we had to do is just change the code to that. So the forward sequence now isn't to bring them all low, but to pulse it low. So output 1 goes low, that starts the sound sequence, wait for a little while and bring it high again. So I've now got a pulse to make it happen. And then reverse, where it says low and high, we can do the same thing in reverse. So a couple of changes of lines in the code, and now it works the exact same way as before, but it can handle the WTV020. You don't have to change that for everyone in the sequence, only the ones that are using the WTV020 module. The rest can simply be held high during the whole time of the forward sequence, held low all the time during the reverse sequence.